All right, let's get started then. Welcome. This is IO 314. My name is Fabio Yeon. I'm one of the engineers on the Google Container Engine team and a tech lead on the team as well. Google Container Engine and the path to cloud native operations, or as I like to call it, the Pi Talk. Wow, no math person in the room. All right, so start with the basics, containers. How many people here have used or are deploying containers in production? Wow, that's a pretty good number. How many of you have played around with containers in general? All right, how many people have heard about containers? There, okay. So let's start with then some simple intro. What are containers? The most succinct explanation I've heard of a container is that a virtual machine virtualizes hardware. A container virtualizes a kernel. So what happens then is if you have a bunch of containers on the same machine, they're all sharing the same kernel, but the container runtime provides enough abstraction so that each one of them thinks they have the machine for themselves. So why are they useful? Well, in this little box called a container, you can put in just your application, its dependencies, and you're done. Compared to what you had to do to set up a deployment on a VM or a bare metal, you don't have to install an OS. You don't have to configure your networking. You don't have to configure and set up the dependencies. It is just you, your application, your binaries, and a little container image, and you're done. In many ways, this is what I call getting serenity in a sea of chaos. Oops, clicker. So once you start playing around with containers, you start running into a little more complicated, complex scenarios. And this is where Kubernetes comes in and kind of helps you out. Your little box, if you have like one or two of them, sure, it's easy to get them up and running and deployed. Once you start getting more of those, then you start getting a little bit more help. Kubernetes helps you ensure that there's a place for your container to run, make sure that the proper number of them are running, make sure that the network packets intended for your containers gets routed properly through the cluster and arrives at the appropriate place. And of course, if you use Kubernetes, Google Container Engine provides to you the best and purest Kubernetes experience you can get. Beyond just allowing to set up a Kubernetes cluster easily, Google Container Engine strives to provide to you management capabilities that makes it easy for you to maintain and keep your Kubernetes cluster running. So, the short little intro, let's dive in a little bit into what I'm going to call cloud-native management capabilities and kind of show you some of the things that we do in Google Container Engine to help you be more productive and to care less about the machinations of your clusters and go back to what you want to do more, which is maintain your applications and your services on Kubernetes. Change is the only constant in life. I like this quote for many different reasons, but that's because in your little container box, you have been able to provide a level of stability on your on your applications and your service. Remember that around you, your clusters, things may be changing continually, and you have to have a little strategy to be able to manage some of those changes. So just a quick overview of the agenda. I'm going to talk a little bit about Kubernetes, the Kubernetes versions, and why the version management is kind of important for you. Talk a little bit about node health, what it takes to maintain your node health and how to evaluate that. Visit a little bit about operations logs, and then talk about some strategies that we have come up with for successful operations of your cluster. So, keeping up with Kubernetes. So remember, Kubernetes is an open source project. As such, it has its own ecosystem, it has its own community, and it also has its own release cadence. Kubernetes strives to get one minor version release a quarter. Now, this is where a minor version is like a 1.4 or a 1.5, or sometime later this month, I think a 1.6 is slated to come out. It seems seemingly like a small thing, it's just a small number change. But because Kubernetes is still a fast-moving, fast-developing platform, every quarterly release tends to be a fairly large release, a fairly big release. New features gets launched, some existing features get upgraded from alpha to beta, beta to GA, and so forth. So every minor release of Kubernetes comes in with as a big package. If you look at the release notes or change logs for every minor release, it is very comprehensive, it is very extensive. Beyond that, every couple weeks, patch releases come out. These may be bug fixes, security fixes, small improvements that were missed, and so on. In Google Container Engine, our goal is to provide to you the latest version of Kubernetes as quickly as possible. Order days if possible, but if not, sooner. And we also provide with you a collection of versions because we understand that not everything is perfect, and therefore sometimes you want to hold back a little bit. So we provide to you the latest version of Kubernetes, one older version, plus the latest version of every previous minor version that's been released. Now, I know that's a little hard to parse, which is why I put an example here. Currently, the latest version of Kubernetes available is 1.5.3, and that is available. The previous version of that is 1.5.2, which is the previous patch release of 1.5. And then we try to provide you the latest version of the 1.4 branch, which is 1.4.9, and the latest version from the 1.3 branch, which is 1.3.10. So why this collection of versions? Why this seemingly some set of minor versions or not others? In Kubernetes, the master and the nodes can be running different versions of Kubernetes binaries. And the official support states that, and by the community and so forth, is that the master and the node can differ by at most 2 minor versions. So if the Kubernetes master is running at 1.5, the oldest version of Kubernetes that can be running on a node and still be considered supported is something in the 1.3 branch. 1.4, 1.2, 1.5, 1.3. When 1.6 comes out, that will go up to 1.4. Anything beyond that, meaning that any version SKU beyond those 2 minor releases, is considered out of support by both Kubernetes and Go Container Engine. It goes into what is called best effort. Your node may still be running, it may still work, but the likelihood is that some functionality may or may not work, and it may break in the future. So Google Container Engine, remember, will also automatically upgrade your cluster masters. This is one of the things that we offer to you when you create a Kubernetes cluster on Google Container Engine. Among the things that we do in managing your master is to upgrade it to ensure that it is at the latest version of Kubernetes. So, as an example, if 6 months ago you created a Kubernetes cluster on Google Container Engine at version 1.3, at some point your master was upgraded to 1.4. And if you didn't do anything in your nodes at 1.3, you were still okay. It's one version difference. At some point in the near past, it was probably upgraded to 1.5. So now your master is at 1.5 and your nodes remained at 1.3. And 1.16 comes out, and at some point in the future, when Google Container Engine upgrades your masters to 1.6, if you haven't upgraded your nodes, you are not officially out of support. So even if you do anything, because of the management of the master and the auto upgrade that exists, you have to upgrade your nodes at least once every 6 to 9 months to at least stay within the support band. Of course, we highly recommend that you upgrade more often to pick up some bug fixes and security fixes that may periodically show up on Kubernetes. So we come now to the first feature that we have on Google Container Engine to kind of help you manage some of this change. Node auto upgrade. Just like master, the cluster master, where we manage it for you, node auto upgrade will monitor the nodes that you have in your clusters, and if we detect that it is, shall we say, older than the master, we'll automatically trigger an upgrade of the nodes. It is the same exact logic that is applied if you upgrade your nodes manually. It can be enabled and disabled at any time. And just to go very briefly, you can actually do this whether the auto upgrade is enabled or not. You can always upgrade your nodes manually first if you want to try out, test out things, or try to get the latest version into your cluster sooner. And we kind of try to do this also in a very judicious manner. Patch upgrades, because they're typically bug fixes or security fixes, tend to be applied much more quickly. So if my nodes are at 1.5.0 or 1.5.1, for example, and I enable this feature, I will probably be upgraded to 1.5.3 fairly quickly. Because we understand that minor version changes of Kubernetes can be more disruptive, and even though Kubernetes and the community tries very hard to make sure that it is not very disruptive and backwards compatibility and all those things are taken care of, but because we understand that sometimes they can be a little bit more disruptive, minor version updates happens at a slightly slower pace. So for example, the 1.4 to 1.5 upgrades will happen at a later cadence than the minor patch releases. So how to enable this thing? You can enable it in the gcloud when you create a cluster. It is on the gcloud beta channel set of commands. The flag is enable-auto upgrade. You can also do it when you create a node pool, and you can also do it in the UI at cluster creation time. Like I mentioned, you can also enable or disable this capability on a node pool at any given time. One thing to keep in mind, if you disable this feature while an auto upgrade is running, it will run to completion. It will just mean that next time you do a scan of your cluster, it will not auto upgrade it. Now, let's peek a little bit behind the scenes as to what Google Container Engine is doing for you when this thing happens, and go over this set of scenarios in case you would want to opt out of this and do it yourself. So, first things, as I mentioned before, you can always trigger upgrades manually. Does not affect the settings for auto upgrades. First thing is that every week, Google Container Engine does a push, and we do release notes. Among the things we publish on this release note, along with bug fixes and feature announcements, is what versions of Kubernetes, if any, are made available to you as a user. If you want, we also provide the same functionality or notification, both in the CLI via gcloud, whenever you list it, or in the UI. Notice that the two versions that are listed in this particular output have two different types of asterisks. The more asterisks there are, well, typically the worse, the more dangerous or worse it is. In this case, it is telling you that one of my cluster is one version behind, and the second one is two versions behind. I unfortunately did not have one that was 3 versions behind, but you can imagine that it would be, the warning would be even more severe than this one. And in the UI, of course, I think there's the upgrade available notification is available as well whenever an upgrade is available for your nodes. If you want something a little more programmatic, gcloud container get server config will give you all the current information about the potential configurations of your Google Container Engine for a particular zone. In this particular output, you can see that the default cluster version is 1.5.3, but the valid masters are now 1.5.3 and 1.4.9, which is the latest version from 1.4, which we still are currently supporting at this time. And then your nodes can be any number of these versions. Notice that even though 1.2.7 is still available, it is only supported if you actually have your master at the 1.4 branch. If you have a master in the 1.5 branch of Kubernetes, the oldest version of Kubernetes that could be supported on the node is in the 1.3 branch. So, picking a little bit back, I mentioned that Google Container Engine manages your masters, and one of the things that we do is upgrade them. You yourself can trigger an early upgrade of the master before we get to it, if you so choose to do it. And the option is from the command line, there's a Container Engine upgrade, and then you add the -- master option. This tells the system that you want to upgrade the master. And then you can go ahead and trigger a manual upgrade of your nodes with the same command, except this time we just take out the dash dash master. Why do we upgrade the master first? It's because the node can at most be at the same version as the master. You cannot have a node that is a version higher, even a patch version. So in the hypothetical world, if 154 were to come out today and made available to container engine customers, if you want to try out 154 before we upgrade your cluster, you would have to upgrade your masters first to 154, and then upgrade your nodes, your node pools, to 154 manually. And this is regardless whether you have enabled auto upgrade for your nodes or not. You can just you can just do it yourself. So you start doing an upgrade, or we trigger an upgrade of the nodes, and you detect that something is going awry, something has gone wrong, and you just need to stop. We have two sets of commands that are currently in the alpha channel of gcloud. The first one, actually the second one on this list, but I think the more important one is you just want the upgrade to stop. So you call gcloud alpha container operations cancel and give it the operation ID, which you can get it from listing the operations currently running. The operation list is probably going to say something like auto upgrade or manual upgrade, cluster upgrade, node upgrade, I think. And you can cancel the operation. Canceling an operation does not stop an ongoing upgrade of a node. So if your cluster has 5 nodes, and you detected that after the first one, something has gone south and you want to stop, if the second node's upgrade has already started, the canceling of the operation that upgrade will finish. But the subsequent upgrades of the nodes in that node pool will not start. The upgrade will be canceled at that point. Now, your cluster is going to be in this kind of a mixed mode version between a couple of nodes are in the new version, a couple of nodes in the old version. So then you can do what's called a rollback. If you call gcloud alpha container node pools rollback, we will then take those nodes that were at the newer version and roll them back to the previous version. A couple of things to keep in mind as well as you're doing this. This is a recreation of the VM. So if you happen to have any local configuration or local data stored on those VMs, they unfortunately they don't survive an upgrade operation at this time. Healthy nodes, healthy clusters. Keeping your nodes healthy can be a little tricky. The nodes can go unhealthy for a number of reasons. You can run out of resources. Maybe you over-provision stuff and you use too much memory, too much CPU. You can run out of local disk. Maybe you have a configuration problem or a bug in Kubernetes that is causing it to crash. Maybe your workload is triggering a kernel bug, or, of course, network segmentation, network drivers crash, so on and on. Some of these are auto-recoverable by Kubernetes, specifically the first two, where you run out of memory or resource. Some signal is provided to Kubernetes to the cluster master, and the rescheduler controller on the master is supposed to observe these things happening and say, oh, this node is overloaded. Let me just take away some pods from it and schedule them elsewhere. So they're self-healing for the most part, as long as you have enough resources in your clusters, and there's nothing you need to do. But if your kubelet starts crashing on you, if your current node became deadlocked because you happen to trigger a kernel bug, what then? This is where it starts getting a little more interesting. The second thing to remember about node health is that it is the master's evaluation of your node's health that is important. Why? Because it is the cluster master that determines what pods are scheduled where. So if your master thinks that your node is unhealthy, or vice versa, you may not schedule anything on it if it thinks it's unhealthy. Or if it's giving a false signal that is healthy, but it is not, you may try to schedule work into an unhealthy node. So there's something to keep in mind, it's kind of important, is that the self-evaluation of the health of the node is less important here. It is what the master thinks of your node's health at that time that is important. And of course, repairs like upgrades are typically limited to recreations of the node. Oops, wrong button. So this comes to the second capability we have on Google Container Engine to kind of help you manage your cluster. It is node auto repair. It is the semantic equivalent of the master repair that we already do for your cluster today. But this is where we are observing and monitoring your nodes. We are taking into account the master's view of your node health state. We're also evaluating other signals around it. We take a look at the signals from the managed instance group backing your node pool. We also sometimes take a look at the signals provided by the node itself. With those signals, at the aggregate of it all, we come into an evaluation whether your node is healthy or not. Too many unhealthy signals, and we will trigger a repair, or in this case, a recreation of the node, in an attempt to get it back into a good state and have it rejoin the cluster. We also try to make sure that we rate limit this so that we're not doing this too often. Now, why rate limit? It's because sometimes the node going unhealthy may be triggered by your workload. And if you start triggering this way too often, we may be in a situation where the node never is live long enough to do any useful work. So we do some of this rate limiting as well. Currently in beta, as a matter of fact, I think it's rolling out as we speak. And so fairly soon, you should be able to have this capability show up in the UI and in the CLI as well. How to enable it? Just like auto upgrade, the flag is -- enable auto repair. You can do this at cluster creation time, at node pool creation time. And as a matter of fact, I would highly recommend that you enable both of them, auto upgrade and auto repair, to make your life a little easier when you run Kubernetes on Google Container Engine. One more thing before I go on to the next slide, which is not here. You can also enable and disable this at any given time. It is just like for auto upgrades. You do a gcloud beta container node pools update, and you can enable or disable auto repair on your cluster, on your node pool at any time that you want. So let's now peek into behind the scenes and see a little bit of what Google Container Engine is doing on your behalf, and kind of give you an idea if you wanted to do this yourself, what kind of things you have to do. So I mentioned that it is the master's view of your node health that matters. So how does the master know what's going on in a node? The kubelet publishes to the master periodically a bunch of information. And one of them is its evaluation of its node health plus what's going on in its internals. All this information is available from the node object from your Kubernetes master. So from the command line, you yourself can get the same data by calling kubectl get nodes. Of course, in this output, it gives a little more formatted, shortened version of it. But if you see the JSON or YAML output, you can actually get at the raw data. And a little bit in the demo, I'll kind of show you how you can look for this. So you have you're listing your nodes, and you determine that one of them has gone unhealthy, not ready. So what are the steps now for you to try to get back to a good state? Well, the first thing you should do is cordon off your nodes. What this thing does is tell the scheduler, hey, regardless of what's going on this particular node, don't schedule any further work on it. Next thing we do, we attempt to do a drain. Try to do a graceful drain of all the pods, make sure they all go away someplace so that the pod becomes empty. This may or may not succeed, depending upon the state of kubelet and other things on your node. If your node has hard deadlock because of a kernel issue, this may not work. But at least we try. The next thing is we try to list your managed instance group backing your node pool. And from that managed instance group, we have to identify the specific node from that, and then try to tell the managed instance group, hey, please recreate that node. Because we have set up, on Google Container Engine, we have set up your cluster using instance group templates. A simple recreation of it using the existing template gets you back a node into your cluster. Operations log. As we start getting more and more capabilities on Google Container Engine to help you manage your cluster more easily, a question that keeps coming up is like, hey, how do I find out when you guys have done something on my cluster? So the first step that we have done right now is that we are augmenting the operations log for Container Engine to contain more information about when we do automated operations on your clusters on your behalf. So before we had repair clusters and upgrade masters available, and we're adding auto repair nodes and auto upgrade nodes as additional operation log types, so that you can find out whenever we have done these things on your behalf. How do you get to the operations log? Well, gcloud container operations list will give you an order list of all the operations that have been done on your cluster. Actually, I think it's beyond just your cluster is in your project across your clusters. And then if you do a container operations describe on an operation, it gives you a little more detail as to what we did and what the status was. Were we successful? Did we fail? So on and on. Node pools and resource management. Another favorite topic of mine. How many people here have heard about node pools or have used node pools? Handful. OK, good. So what are node pools? Node pools, at its shortest definition, is just a collection of nodes managed together. From a Google Container Engine perspective, what it means is that you can have multiple node pools in your cluster, each defining a particular configuration. And when I say configuration, I mean machine type, machine resources, and Kubernetes versions, scopes, and on and on. Within a node pool, all the machines have to have the same exact configuration. They have to be the same exact machine type. They have to have the same exact machine Kubernetes version. They must have the same exact machine resources. So if I ask for an N1 standard 4 with, let's say, 2 local SSDs, every single machine in that node pool will have the same configuration. But of course, I can have multiple of these in a cluster. So this gives me an additional level of functionality, flexibility as well, where I can have different machine types and mix and match these to meet my workload and my resource needs more carefully. And this is also a foundational unit for many management stuff that I talked about. So before I was talking about cluster creation, enabling it at cluster creation or node pool creation, when you create a cluster on Google Container Engine, what is actually happening is that we're creating the master and so forth, and we're also creating a default node pool for your cluster. So all the options available for creating a node pool are available on your cluster creation as well. So let's take a look at some things that we can do with node pools that might be kind of interesting. So can we switch to the demo machine, please? OK. So you go container, clusters, list. And here I have my cluster that I created for this demo. It is currently running on master 153. And oh, wow, my master was upgraded since I ran this demo. So my nodes right now are version 152. So now I have a notification that a node upgrade is available. It also tells me that my current cluster is running and, of course, my master IP address. Let's take a peek underneath then at my node pools for this particular cluster. Of course, pedantically, it has to be plural. I have 3 node pools configured for this cluster. I have a main pool comprised of N1 standard 4s. I have something that I call a pre-pool of N1 standard 2s, and something that I call a low-man pool, which is running the custom machine, a custom 2048, which signals to me that this is a 2-core machine with only 2 gigs of RAM. Let's then describe the main pool. Oops, let me pipe that. OK. N1 standard 4, authentication scopes defined, the number of initial counts enabled, and of course, in our management, you can see that I have enabled both auto repair and auto upgrade for this particular pool. OK, nothing too interesting on this one. But if I go to my pre-pool, among the things that you'll notice on this particular listing is that this thing is comprised of preemptible VMs. Preemptible VMs, of course, are a option provided to you from on GCP, where the costs for these are lower, but in return, the VM may be preempted underneath of you with a moment's notice. But if you have a workload that are preemptible, preemptively friendly, or can be preemptible easily, this is an easy way for you to instantiate a couple node pools in your cluster that have this and leverage it, the lower cost that they provide. And then, of course, the final one, which is my low mem pool. It is just like my main pool, except the difference here is that I'm running in custom 2048 machines. So like I said, very low memory, high CPU kind of workloads would benefit from this kind of node pool. So previously, I have already pre-deployed a number of pods on this particular cluster. So let's take a look at all of them, make sure they're all running. So I have deployments that are very high CPU, some deployments that are just regular main workloads, and I have something that I'm calling preemptible workloads, or workloads that are eminently preemptible. With a little bit of trickery, and this is where I will cut and paste the command, because I can never remember from memory. I called kubectl get pods, provided a JSON path that says, hey, fish out these little fields from your particular listing, and then combine them to provide this output. So in this view, you can see that all my pods are listed there like before, but now I'm also listing which node they're running on. And you can see this thing scattered all over the place. I have lots, my high CPU workloads running in a variety of different machines, my main machines. I have main workloads running in a variety of other machines. But more importantly, maybe not a good idea, I have some workloads that are running on my preemptible VMs. Should be OK, maybe, but certainly not ideal, because maybe they're not workloads that you want to run on a preemptible VM. So how do we then take care of that? Let's take a look then in a node and see what we can find out. So if I list the raw JSON object for a node, you'll notice a couple things here among the metadata and so forth, is that there's a whole section for labels. Some of these labels are applied on each node by the Kubernetes runtime, and they're identified easily by the kubernetes.io prefix. So things like machine architecture, AMD64, machine OS, Linux, and down here, hostname of a machine. You'll also notice a few of these that are actually set by Google Container Engine itself. They are prefixed with cloud.google.com. In this case, by default, every single node that we create on Google Container Engine has automatically, as part of it, the node pool name associated with it. And of course, the other thing here is this other label. On Google Container Engine, when you create a node pool, you are allowed to provide to it a common delimited list of key value pairs that become part of your node labels. So you can then use these on your pod spec in Kubernetes so that to ensure that those workloads, those pods, ends up at a node that has this label in them. One more thing that I want to show up while I'm here. This is another node. In this case, this happens to be a VM that is a preemptible VM. When you create a preemptible VM, node pool, in Google Container Engine, we will automatically apply this label as well. So you don't have to do it. You can certainly add more, like I have done below, where I've added the pre-label as well. But you can actually add the Google Cloud you can use this label as part of a node selector on your pod spec as well. Oh, before I go off, I mentioned earlier about node condition. If you want to explore a little bit more about doing the node health evaluation yourself, every single node contains this array of node conditions under the conditions list. And there are a variety of these. Some of them talk about route health, disk, memory, pressure. And of course, the bottom one is whether the kubelet is ready or not. This is part of the signals that is pushed from the node to the master periodically to let the master know what the status of the node is. And this is the signal that both the master and Google Container Engine uses, well, one of the signals, to determine whether the node is healthy or not. So back to this demo. I have then a deployment YAML for my high CPU workload. Of course, I have commented out for demo purposes the node selector. So let's go ahead and delete the comment tags and make sure that the node selector is there. I'm going to go to my other workloads as well and remove the node selector comments. And notice that on this one at least, while on the other ones I've used my custom labels that I've set up on each node pool. On this one, I just decided to use the one that Google Container Engine sets for preemptible VMs. Might be kind of nice because at this point, I'm not relying upon a custom label that I've set or the pool name or anything like that. I'm just using an automatically set label that Google Container Engine has put on it. So it's available across any VM that is preemptible. Let me go ahead and then replace the deployment on Kubernetes. And preempt. OK. Keep control, get pods. Bunch terminating, bunch running, bunch container running. We'll let this run for a little bit. Let everything kind of settle down again. Wow, taking a little bit longer. OK, things seem to be settling in, settling down. Things are getting scheduled. Excellent. Everything is running again. So if you go back to that somewhat complicated kube control that I had before, what you'll find here now is all of my high CPU deployment, it is now running on my low memory pool. My main workload is my main pool, but more importantly than anything else, my preemptible friendly workload is now all scheduled and running on preemptible VMs. So with this, I was able to, shall we say, ensure that my high CPU workloads end up on machines that have very high CPU, low amounts of memory, save me some money, ensure that the proper VMs are assigned for those. My main workload can be whatever. My generic set of workloads can go on the main workload. But more importantly, my preemptible workloads that low priority, low cost are all set up and now are all running on my preemptible VMs, exactly as I desire it to be. Couple more things to keep in mind. There are more node selector options becoming available to you as part of the Kubernetes 1.6 release. So, for example, node selector right now is a match. One of the things that is coming up that might be kind of interesting, especially in this kind of scenario, is the anti-affinity. So you may have workloads that, like, I don't really care where they run. I just don't want them to run on this type of VM, preemptive VM, for example. So that's one of the options that will come online, available in the 1.6 timeframe, I believe, where you can just state that in your pod spec. It'll be available on your when you deploy them. So can we go back to the slides, please? All right. So a couple slides I put it in here for you to as a reference. Feel free to take a look at it. How to list some node pools, how to create the node pools that I've used for this demo. Notice the machine types. Notice the -- preemptible option as an option, and the node labels, how to specify these on your node pools. And of course, in assigning pods to node pools, it's the node selector option in your YAML file. OK, some final notes. Upgrades can be disruptive. So to kind of help mitigate them, you can use the upgrades are per node pool. So you kind of use them to segment the upgrades of your cluster so that you can kind of have either kind of a canary test kind of node pool. You can try out new versions. So you have an existing workload that is running at version 151, and you want to try out 153. You can spin up another node pool at 153, schedule some workload on that particular node pool, make sure everything works fine before you let the rest of your cluster be upgraded. Consider having what I call the one node slack to ensure proper capacity. When we do upgrades, we take down one node, do the upgrade, bring it back up, go on to the next node, and so on. While the one node is down and being upgraded, it'd be kind of nice for you to have enough slack on your cluster so that whatever pod was running there can find a new home while the upgrade is occurring. Google Container Engine limits you to having one cluster operation running at any given time. Now, just to differentiate between the container engine operation versus a Kubernetes operation, for example, these are things like adding or deleting a node pool, updating a cluster-wide configuration, doing an upgrade, a repair, any kind of events. All those are serial on Google Container Engine for various logistic reasons. So for the most part, this restriction is not a big deal, except if you're upgrading a fairly large cluster or node pool. And you can imagine that because we're doing the upgrades sequentially, it may take a little while for it to complete. In the middle of it, if you have to do something on your cluster, go ahead and cancel the upgrade. It will stop at a good point. You can do whatever operation you have to do on your clusters, and then reissue the upgrade command, and it will just kind of pick up from where it was left, scanning your nodes that we have, skipping those that have already been upgraded, and just keep on going the rest of them. And of course, we're continually trying to make progress and try to minimize some disruptions. And we have more capabilities that we're going to be adding in the future for upgrades and repairs. Some of the best practices that we have found, pod disruptions are a reality. Try to prepare your workload for them. There are a number of capabilities being added to Kubernetes to kind of help you with them. So please do take advantage of them, and we'll keep integrating them into Google Container Engine. Do you use deployments and replica sets for your pods? Make sure that you have enough sufficient redundancy. The second point is actually kind of important. In the cloud-native world, please do not write set once and forget configuration scripts. The mindset that you need to have is reconciler. You need to write reconcilers that read the current state. If it's not the desired state that you want, do some action to try to get there. And then once it's completed, go to sleep. And then start over from step one again. This way, whether it's a repair event, an upgrade event, or some other things that are happening outside of your container, if you have some configuration that you absolutely need, you know that at some point, if it goes out of alignment for whatever reason, it is a temporary thing that hopefully should auto-correct itself. And of course, please use node pools. Organize your resource more efficiently in your cluster, allow you to have heterogeneous configurations, leverage different types of machines, different types of resources, and so on. Quick recap, change is constant, basically repaired. Do enable auto upgrade, and then try out auto repair. Operations logs, please look into them to see if, whenever we do something, we'll try to make sure that they all end up in your operations log for your clusters, so nothing is hidden. Use your node pools to organize your resources, and of course, think reconciler, not set and forget. For those that may not be familiar, here are a couple links for the Container Engine website, the Google groups where the release notes come out, whenever we do a push on Container Engine. A lot of members of our engineering team are on Stack Overflow, so if you have a question that is Container Engine specific, please use the tag, the Google Container Engine tag in Stack Overflow. And of course, as always, the Kubernetes GitHub repository, highly technical, kind of complicated, but always looking for contributors for the Kubernetes project. And while you're here at GCP Next, highly recommend going to other container talks if you want to find out more about us. IO 205, I think, is this afternoon, and it's a good intro to the other capabilities and features that are being added to Google Container Engine. And of course, I also want to highlight IO 307, even though the title says ABC is a Google Container Engine tips and best practices, is actually a talk mostly about monitoring with your Google Container Engine cluster. And with that, I want to say thank you for coming.